This is the review for the exponentials and logarithms test. And our first problem says graph the exponential function below and then complete the subsequent steps to graph the inverse function. Label each graph with its equation. So if we pull up our calculator here and we type this in, we go to y equals, and we're going to type in 1 divided by 2 to the x. And we can look at the picture here, but what we really want is we really want to fill in that table. So what we're going to do is we're going to go to second and graph, which gets us up to the table feature. I need to scroll up a little bit here to get some more points on here. And what we see is we have negative 4, 16, negative 3, 8, negative 2, 4, negative 1, 2, 0, 1, 1.5, and 2.25. And once we have that table, we can fill this in. And negative 4, 16 is going to go off the graph here, but negative 3, 8, negative 2, 4, negative 1, 2, 0, 1, 1.5, 2.25. So we get this picture. Same picture that we saw on our screen. And this function here is our f of x. And there appears to be an asymptote at, well, it's going to be the x-axis. And in terms of the asymptote, it would be here in green, along the x-axis. That horizontal line, and that horizontal line has an equation of y equals 0. Now what it says is it says fill in the table below for the inverse of f of x. And what that means is we're going to switch these. Negative 4, 16 becomes 16, negative 4. Negative 3, 8 becomes 8, negative 3. Negative 2, 4 becomes 4, negative 2, and so forth. 2, negative 1, 1, 0, 0.5, 1, and 0.25, 2. And we graph that. So 16, negative 4, again, goes off the graph a little bit. But 8, negative 3, and 4, negative 2, and 2, negative 1, and 1, 0, 0.5, 1, 0.25, 2. In our picture, looks something like this. I'm a little bit off, but you get the idea here. And actually, this graph, the red graph, which shows our inverse function, also has an asymptote. And the asymptote is going to be the y-axis here, in pinkish purple. Remember what the definition of an asymptote is. It's a line that the graph approaches but never quite touches. And y-axis. And the equation for the y-axis is x equals 0. These two functions reflect over the line y equals x, which, when we graph that, starts at the lower left-hand corner, goes through 0, 0, all the way to the upper right-hand corner. And what happens is, if we fold our graph along that black dotted line, the red graph will land directly on top of the blue graph. That's how we can check to make sure that we are correct. The inverse graph, in other words, the red graph here, is actually called a logarithm. And the equation of that red graph is y equals log base 1/2. Remember, that's what we were graphing originally. 1/2 to the x. 1/2 of x. Y equals log base 1/2 of x. Problem number 2. We're writing the following logarithms in equivalent exponential form. Remember that a logarithm is another way of writing an exponent. So when we set this up, it's going to be log base 5. That's the first number written in there. Whatever the logarithm equals is the exponent. It equals 4, so that's the exponent. Equals 625. Log base 1/2. 1/2 is the first number written. 1/2. Whatever the logarithm equals is the exponent. It's going to be 1/2 to the negative 5, because that's what the logarithm equals. And then we finish with equals 32. Problem C. Really important, and it seems not important, but it is. The base on this logarithm, because it's not written with log, is 10. And this is going to be 10. Remember, whatever the logarithm equals is the exponent. So what it equals is 3. That's our exponent. 10 cubed, 1,000. And over here on part D, ln, natural logarithm. It doesn't have to have a base written, but we do need to know what it is, and it just so happens that it's an E. And I can't get that E in there very well, but when we convert this, again, whether it's log or ln, whatever the logarithm equals is the exponent. So our base is E. What it equals is 0, so our 0 is the exponent, and E to 0 equals 1. That's converting the logarithm to an equivalent exponential. We can go the other direction as well. Write the following exponentials in equivalent logarithmic form. Well, the first number on this one is going to be log base 6. Remember, we dropped that 6 down. Whatever the logarithm equals is the exponent. The exponent in this problem is a 3, which means that the 216 must go here. 19 squared equals 361. The first value written there is 19. This is log base 19. Whatever the exponent is what our logarithm equals. We'll get 361 here. So it's whatever has the exponent, it's going to be the base on the logarithm. And it doesn't matter here, a to the g equals f. This one is log base a. Whatever our logarithm equals is the exponent. The exponent in this problem is a g, which means that here is the m. And finally, it doesn't matter over here that we have a fraction. It doesn't matter that there's a negative exponent. Just going to write it down a little bit farther. This is going to be log base 10. Whatever the logarithm equals is the exponent, which is negative 2, which means that the 1/100th goes here. By the way, just like from 2C, sorry, I had a phone call in between, but I was just talking about how we could write it the way it's written, but you don't have to write that base of 10 with log. So the other option is just to write log 1/100th equals negative 2. It still is, whatever the exponent is what the logarithm equals.